Our next speaker is Peter Richardson. Peter is the CEO of Maia technology. One of Maia's products is cloud-based cattle record-keeping software. So we're going to switch sectors here, and we'll welcome Peter to the floor.
Thanks, Richard. Just correct you on one thing, it's not record-keeping software, it's decision support software. But I feel like I'm a little bit different to everybody else in the room. I'm a software developer, and I come from a small startup, and so there's a big contrast with I feel with my background to everyone else in the room. What I've been asked to talk about is what are the changes that are happening in software development, and how can they apply to agriculture? And so I want to pick up on some of the themes, in fact, that Mark was talking about in terms of interoperability, and that have been a theme all the way through the conference. But I want to talk about it more from a software development perspective, because there are some changes in the way that software is being built now that I think do facilitate some of the problems that we're all trying to grapple with, and whether the answer is standards or whether the answer is one great commercial platform. And so that's kind of what I want to drill into in this talk. Let's see if I can get this all working. So, in outline, first of all, I'll just give you a bit of background so you understand where I'm coming from, and I'll tell you a bit about my technology, who we are, and what we're doing in the marketplace. And then I want to summarise the major trends in software development. So the changes and the disruptive changes that are happening within my industry, software development. And in particular, I don't want to talk about all the usual stuff like the cloud and Internet of Things and all the things that we've been talking about really over the last 2 days. I want to zero in on something that nobody else is really talking about and that you possibly aren't aware of, and that is it's a trend towards something called microservice architecture, which is a way of structuring how you build software to make it easier to build larger scale things that can interoperate. And what I want to lead on to is that this new way of building software using microservice architectures is going to facilitate better ways of solving these problems that we're all grappling with in terms of interoperability, and it provides the potential for us, particularly within the sort of local Australian startup market, for us to form alliances and work together rather than having overlapping efforts in terms of how we're building out all this functionality that we've been talking about over the last 2 days. So, who is Maia Technology? Maia Technology is, as I said, is a small startup. We've been going about 2 years. We've just released our first product. It's called Maia Grazing, and it's a platform for decision support in the grazing space. So again, I'm also quite different to most people in this room in that I'm not really talking about cropping at all. I'm talking about pasture and livestock and grazing. And I guess just for your interest, the word Maia, it's not an acronym. Maia is the ancient Roman goddess of abundance, normally associated with spring and growth, and is vaguely related to the Greek earth mother, Gaia, a term you may have heard of. The Maia technology is really formed from 3 pieces. We have a seed investor who has some significant pastoral interests. We have a group of agricultural consultants that are, amongst the leaders in their space, in particular in the grazing area. And lastly, we have a software company called Object Consulting, which is actually where I originally came from, which is a 200-person IT services company, information technology services company, that build software for the big corporates. So that's banks, telcos, insurance companies, government. And the whole idea behind my technology is to leverage that software development capability and the agricultural expertise and the initial seed funding to go after new opportunities that are being created in this digitally disrupted marketplace. Just in terms of why we zeroed in on grazing, because I do feel like I'm a bit unusual here talking about grazing. I really enjoyed Jared's talk from AACO because he really gave an insight into the incredible complexities that are sitting under the covers in the grazing space. The reason that we've identified grazing as an initial opportunity for us as a startup is threefold. Firstly, our seed investor has significant pastoral interests and is looking to get some tooling to help build a vertically integrated beef business, and there were no such tools in the grazing space that they could find. Secondly, we have some terrific expertise through the group of consultants that we're working with that we think allows us to really hit best practice. And thirdly, there's a huge gap in the market. If you look around, there actually there's plenty of record-keeping systems that cover off on livestock and livestock management and grazing, but there's really no decision support systems that we can find anywhere in the world that do the sorts of things that we're talking about. And we formed our startup on the idea that there's a small number of innovative farmers that are doing significantly better than the average, just like in most other fields of endeavour, I guess. And what we're trying to do is identify those outliers, the super high performers, and then codify the best practice of what they do into a set of decision support tools, and to then simplify those tools down so that we can take those more sophisticated techniques and bring them into the mainstream. And so you would have seen a few of the speakers have used this analogy of the technology diffusion curve and crossing the chasm, and that's all based on a book by Geoffrey Moore, which is well worth a read if you're wondering what the chasm is all about. And we're consciously making the decision that what we want to do is grab the innovators, figure out what they do, figure out how to simplify it and make it doable by the majority, and then take it to that majority and package it up and deliver it in a software platform through service providers. Go. Use the backup. If you look at the best graziers, the graziers that are getting the best results at the moment, they heavily plan. They work out how they're going to move their mobs through their paddocks, so to take advantage of the non-linear growth patterns of the pasture, and to stimulate the growth through managing the graze and rest periods to maximise the yield they can get in terms of overall live weight production. And they often do that through things like paper grazing charts, where they're mapping out how they're using their mobs to work their way through the pasture to maximise that yield. And a small number of those leading graziers are now trying to do all of the maths that sits underneath all of this through spreadsheets, and so they're building these quite complicated spreadsheets in order to work out the optimal way that they can graze their pastures in order to maximise yields. But what they really want to do is be able to get all that information at their fingertips, out in the field on their phone or mobile device or whatever, so that they can make decisions on the spot with up-to-date information and have it recorded at the time when that action is done. And that's basically what we've done. We've sort of looked at how all of those processes work, and we've built a platform that lets those graziers make those decisions very, very quickly and very, very easily. And I'm not going to go into the details of what our product does, because that's not the point of my talk, but just to illustrate on this picture, this is just a picture of the dashboard, and what the dashboard's really showing here is there's a blue line there, and that blue line is the rolling 365-day stocking rate, normalised for the rolling 365-day rainfall. So it's giving you a really good idea of how you're tracking, and there are some horizontal lines there, and the top grey horizontal line is the carrying capacity, so we can generate an inferred carrying capacity for that group of paddocks or that part of the property. And the whole goal of our software is to help the grazier match the current stocking rate to the true carrying capacity of the land in order to optimise their production. And you can see here this one's actually running away. The blue line's actually taken off above the carrying capacity, and so some action is going to be required. So, trends in software. So this is my sort of quick list of all of the sort of sexy stuff that's going on in the software and information technology industry at the moment. And we've talked a lot in this conference about the Internet of Things, and I love the idea of every cow having an IP address on the internet. And as a geek, it's a fantastic idea. But I think we've really sort of talked enough about that so far, so I'm not going to touch on that. And similarly for drones and autonomous or near autonomous vehicles. Nobody mentioned virtual reality, But I think you'll find virtual reality will potentially become relevant when we start to visualise these complicated data sets in 3 dimensions. Virtual reality tools can be a useful way of navigating through very complex data in simplified fashions. And so I'm not really going to talk about that in any detail, but I'll just flag that it's something that you might want to keep an eye on just when you're starting to talk about the more complex data sets that everybody's been talking about over the last 2 days. Big data and identity we've talked about to death, and pushing things up into the cloud, to me that's become pretty much of a no-brainer, notwithstanding the issues with network connectivity. And there are lots of ways of getting around those network connectivity problems, obviously fixing the network being first and foremost, but also having disconnected and synchronised devices working with the cloud so that you can cater for periodic connections and so on and so forth. But really what I wanted to talk about was the last item on this list, and it's a trend amongst software developers to something called microservice architectures, and it's centred around ways of structuring software through using application programming interfaces to make it easier to build software more rapidly. So let me explain what I mean by microservice architecture. On the left-hand side of this picture, you've got the typical structure that a piece of software is built in. Historically, I've used this very complicated notation where there are sort of squares and triangles and stars and hearts, which just simply represent the different concepts that might be being related together in this theoretical piece of software that's being built. And the point on the left-hand side of the picture is that there's a whole lot of complicated and interconnected relationships between a whole lot of different concepts, and they've all been bundled up into this application, and they're talking to this consolidated database that contains all of the data around those ideas. And then they're delivering functionality out to users. But they're building it as a kind of a monolithic platform. And the trend in microservices architecture is to break down the complexity of the left-hand side of the picture and to create a set of very simple services that represent a single idea and to expose interfaces to those single ideas, and then allow application developers to knit them all together to create applications very quickly and very rapidly. And that's kind of what's going on the right-hand side of the picture, where the triangles have got their own little interface and their own little way of being managed, and similarly for the squares and the stars and whatever. And then in the middle there's an application that's been built by just knitting these things together to create some piece of functionality that a user wants. And I know I'm sort of grossly oversimplifying things, but I'm just trying to get across the fact that this is actually having a big impact on how software is being built, particularly large-scale internet software, because it helps us to manage complexity. And this idea happens to combine very nicely with the cloud, with deploying things to the cloud, because now each of those individual microservices can potentially be autonomous, and it can be deployed out directly into the cloud so that we can mix and match things very quickly. And we don't have to rely on individual complicated services being managed by one person. They could all be managed independently by different organisations. And so we have no particular hierarchy, we just have meritocracy. We combine the things that we want to use. I might just skip over the complexity, I've already mentioned that. So what does this mean for agriculture? Well, there's a lot of potential for shared services, and there's a lot of work going on, particularly within in Australia, around things that could potentially be common services that could be being used by lots of application developers in lots of different sorts of ways. But the current structure of our industry tends to be that in order for them to get co-funding and be viable, there's a tendency for each of these sort of shared service areas to go and have to build applications and end-user platforms in order to be able to fund the work that they're doing, in order to have a long-term future. And I guess what I'm posing to you is that there's a better way of thinking about how all of that stuff can work. And so to do that, I just want to use the example of our platform and the sorts of things that could be done with it. So to cut a long story short, we've built this big complicated model that allows you to do decision support around grazing, and it involves linking up concepts around pasture growth and cattle growth and all the rest of it. And then we've wrapped into that decision support logic and planning logic and a whole set of tools to create this platform that makes it easy to deploy our Maia grazing application. But platforms don't exist in isolation, and so there's a whole lot of sources of interesting data and analytics and useful services that our platform could potentially use that we couldn't possibly hope to build out ourselves as a small startup. And I would argue that, in fact, there's no one vendor that could build out all of this kind of functionality. So what we really want to do is be able to access all of these different things in ways that allows our particular platform, but also other platforms, to be able to leverage all of that diversity and rapidly deploy new applications. So let me just give you a couple of examples. The first one is we're about to release a really simple little free app that runs on your phone that lets you do some pretty interesting things with rainfall to help graziers make decisions. And the way we did that was that we exposed a microservice on our platform that was basically allowing you to get to the property rainfall data that was being managed within the platform. We also wrapped up some Bureau of Meteorology services into their own little microservices so that we could very quickly create an app that combined those things together to do some sort of sexy things with rainfall to let graziers make better decisions. And what it meant was that we could very quickly create the app without having to, and have it leverage a huge amount of back-end grunt. And what we want to do is make that opportunity available to third parties so that anyone could create those sorts of apps. The second example I wanted to use was the NRM Spatial Hub, or the Pastures in Space guys. Similarly, they've got some fantastic data that we could be using. They can start to measure growth rate of pastures and current amounts of biomass, and they can feed direct data into our platform that will help with our decision making around making grazing decisions. And similarly, they have a need for data flowing back into them that allows them to calibrate their models based on what's actually been taken off the pasture, what are the stock actually eating, and how is that going, because that's also a very dynamic process. And so the right way to do that is, instead of having them go off and build their own grazing application, what we can do is expose microservices in our platform, and they can expose microservices in their platform, all deployed up onto the cloud, that will let us exchange data so that we can work together and leverage each other's capabilities without either having to go and build out all of the functionality of the other. Might just skip over the carbon farming stuff for the time being because we're short on time, because I did want to round up by saying, so if you net all of this out, there's the potential for all the various people that are working in this space here and overseas to have an architecture where there are viable business models at different layers of service offering. So at the very bottom, we've got data analysis services, and they ought to be able to create business models that will allow them to syndicate out their data and their services so that platform and application vendors can leverage all of that information without them having to go and build their own vertical application suites, which is something that they have tended to do. And then you've got the platform aggregators that are leveraging all of these underlying data services and then packaging them up to make it easy to build these enterprise applications like Maia Grazing. And then at the very top, you've also got these very simple apps that need to be quickly and easily built, that need to be able to leverage all of the stuff that sits underneath everything. And I guess I'm just saying that we ought to be creating an industry structure, and we ought to be setting standards and agreements that's going to allow these sorts of interactions to occur without us all overlapping and duplicating effort and deploying capital in the same way to do the same thing in many different places, because that's incredibly wasteful. So where Maia technology lives is we're not trying to cover all of those layers of this structure. We're really focused on just building an intermediate platform that combines together some of these data services, exposes things up, and makes it really easy to build applications like the grazing decision support system. So to close out, in order to realise that kind of a vision, we require some common models and standards, and that's been alluded to before. And one answer to common models and standards is that a particular vendor does everything, but I would argue that that doesn't tend to work at scale, and what you end up having is some kind of interoperability models, some big players and some small players, and you want them all to work together. So there needs to be a level of co-opetition, of cooperation amongst competitors, particularly within Australia. And I've been speaking to a lot of different players in the industry over the last couple of days, and there's a lot of interest in trying to avoid overlapping effort and working together. And it requires a vision for how all of these things could work, and the fleshing out of the picture that I showed before, which was necessarily very brief and simple. The good news is that there's actually a lot of work being done on this, particularly overseas in the US. There's the Ag gateway people who are standardising on interoperability models for e-business and supply chain integration, and the Open Ag Data Alliance, which is defining these. They don't actually use the term microservice, but in actual fact, it's a consequence of the microservice architecture. They're defining these application programming interfaces that allow for interoperability between all these different vendors. And that does avoid the many-to-many API problem that Mark was talking about before, because there's a common language that's being passed around between all of these vendors through these standards. And I guess all I'm saying is that when I look around at Australia and the startups within Australia and the software vendors within Australia, I think we could do a better job of getting together, maybe forming some kind of an alliance and figuring out how we could work together to collaborate and not duplicate each other's business models through getting involved in some of these standards, and perhaps even having a local group that could kind of position ourselves into these international standards and represent the things that they aren't looking at in such a great detail, like grazing. So I might stop there. Thank you.